So here we go, guys. Here's the 8 problems, and if you need to see step-by-step solutions, you can definitely look at this video. A couple of the first 4 I think are pretty easy. I think the next 4 after that are kind of interesting. So anyways, polar to rectangular. So let's go with it. This is polar to rectangular. There's my r, there's my theta. I like to sometimes get a visual. This is 7 pi over 4, which is all the way there. There it is, but I want to go -2, which means I want to go in this direction. Okay, so I go backwards in that direction. So that's kind of an important thing to know about if your r is ever negative. Okay, so let's see. X equals -2 cosine of 7 pi over 4, and that would be -2 times the square root of 2 over 2, which is the negative square root of 2. Y is -2 sine 7 pi over 4, which is -2 times negative square root of 2 over 2, which equals a positive square root of 2. So I got negative square root of 2, comma, square root of 2, which agrees with my visual, how it's left and then up. Okay? This one here is another one where you can practice the negative version of an r. 11 pi over 6, super close to a whole way around. It's somewhere on that angle, but I need to go -2. Okay? So, r equals -2 cosine 11 pi over 6, which is -2 square roots of 3 over 2, which is negative square root of 3. Y equals -2 sine 11 pi over 6, which is -2 times -1/2, which is 1. So I'm at negative square root of 3, comma, 1, which looks pretty good because I went left again and then up. So the big thing on the first 2 here is working with a negative radius just means on that angle you go backwards, and that's allowed. Okay? Next guy, now I'm going to go from rectangular to polar. So rectangular to polar, I go 1, 2, 3, 4, down 2. I'm looking at that guy, but in polar style, instead of kind of going right and then down, polar kind of goes directly at it and says, what's that angle and what's that radius? Okay. Well, 4 squared plus -2 squared equals r squared. So r squared equals 20. R equals the square root of 20. Visually, that's that red length. Okay. And then my angle is given by tangent of the angle is y over x. So my angle is negative inverse tangent of, -1/2. So you can say it's square root of 20, comma, whatever inverse tangent of -1/2 is. Okay. Just to check it, I'm kind of curious here. Inverse tangent of -1/2 is -4. So this gets you square root of 20, comma, -0.4636, da 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 da. That's fine. We always go counterclockwise, but in this case, if it's negative, so I know counterclockwise goes this way, but if it's a negative angle, that tucks me in to that spot right there. So it does work because of the negative angle. Okay. This next one, symmetric x and y values. So that should scream to you that this is a 45 degrees. This is right on that y equals x line right here. Okay. So polar wise, I want to know the length of that, and I want to know the angle, which you already do know the angle, but I'll show you the math for it. So 3 square roots of 2 squared plus 3 square roots of 2 squared equals r squared. That's going to be 9, that's 18 plus 18 equals r squared. which is 36 equals r squared. R equals 6. Tangent theta is y over x, which are they're both the same guy, so tangent theta is 1. So theta equals pi over 4. You can say 6 comma pi over 4. Okay, first two are basic conversions from polar to rectangular and rectangular to polar. So those guys should have gone pretty quick for you guys. Now we'll get into some good practice ones, converting rectangular equations to polar equations. So I have the x squared plus y squared minus 2ax equals 0. Hopefully you guys do notice that the x squared plus y squared is already an r squared. Okay, so that might be a good helpful fit. So the question is, where do we go about the 2ax and how do we convert that? So let's just move things around and see if we can jump into it. X squared plus y squared equals 2ax. Right away, this piece is r squared equals 2ax. So I'm halfway converted. I have the r squared, but I have this 2ax. The only way to get rid of an x and convert it is if I had a cosine. Nope. I'm going to start this one again, guys. This is now 5:20 on the same day that I video lectured the first lecture for you guys, and so I am really getting tired. Let's start this one again, and I'm sorry. So, x squared plus y squared. I know that's r squared. And x, the form for x is r cosine theta. So let's just drive right into that and say this is r squared minus 2a r cosine theta equals 0. I will pull out the r. R minus 2a cosine theta equals 0. So I'm either r equals 0 or r equals 2a cosine theta. Now r equals 0 is a point. That's it. That's kind of boring. But this guy is the relevant one. Okay? R equals 2a cosine theta. You might be curious what that looks like. So let's see if we can pull it up on this. 2, go to here and clear it out. Let me see what it is again. It is 2a cosine theta. Let's just practice and say 2 cosine theta. So what's my a in that case? 1. I like to always have it at least from 0 to 2 pi and see if that works. And let's graph that. So if you notice there, you can zoom in a little bit if you want. It's a circle. It's just finally not on the origin. It's actually pushed over and centered at 1. So it's a circle, it looks like, with radius 1. And centered at 1 comma 0. And if you do something like maybe make it, instead of 2a, make it, let's say, 2 times 2, which is 4. Let's see what happens. There, it looks like if I zoom out a bit, it looks like now it's centered at 2 comma 0 with a radius of 2. So long story short, this is turning into a circle centered at a comma 0 with radius a. Now if you want to look at that rectangularly, that would be x minus a squared plus y squared equals a squared. And I promise you, if you completed the square on that, that's what you would get. So I just kind of showed you how to do it by converting to polar. And then I also kind of just played it by hand with the a and playing with different a's and graphing it to come up with a general idea of it. But that's a way to get a circle that's not on the origin, but it's moved off it a little bit. You might be able to make a prediction that if I did 2a sine theta instead of 2a cosine theta, it would have been moved off the origin again, but it would have been moved up and down instead of left and right. So hopefully that one there helps you out on number 22. Let's look at 24. X equals 10. That's it. We already looked at one earlier today that was x equals 1. So x is r cosine theta equals 10. So r equals 10 over cosine theta. R equals 10 secant theta. And we talked about this one before. A lot of students over the years forget that polar can still get you a straight line. Okay? So r equals 10 secant theta. And I like to think about polar as shooting kind of like a ray or a flashlight and hitting something. This is how this would shoot out. And it would just stop at the wall. So the polar thing is swooping through, and it would be moving up it and forming that wall. I don't know if that made sense. I can clarify that tomorrow. Okay? Let's look at the next one. Convert now from polar to rectangular. Okay, so now this is a case where I know that x equals r cosine theta, but I don't have an r with the cosine. And r is pointless unless I say r squared is x squared plus y squared. So both guys here are missing an r. If there was an r on the right and on the left, life would be a lot smoother. So I'm going to multiply by an r. I'm going to go r squared is 5r cosine theta. Now r squared is x squared plus y squared equals 5x. Before I keep going further, this should be similar to one of the ones that we just did. And we know what that looks like. We learned that it is a circle centered at 5, 0 with radius 5. I want to show you that. I'm going to show it to you on this problem here. So let's see if I can take a look at that by completing the square. So I got x squared plus y squared minus 5x equals 0. X squared minus 5x plus blank plus y squared equals 0. Plus a blank. Half of negative 5 is 2.5. 2.5 squared is 6.25. 6.25. I think I made a mistake somewhere, and we will find out where it is. X minus 2.5 squared plus y squared equals 6.25. Let's see. What am I doing? Oops, I forgot to hit pause, but I think I figured out my mistake. Remember on that last problem, it was r equals 2a cosine theta. So if it's 2a cosine theta, I forgot about the 2. So my prediction should really be a circle centered at 2.5, 0 with a radius of 2.5. So let's see here if this is actually turning into that. This is x minus 2.5 squared plus y squared, and 6.25 is 2.5 squared, like we predicted. And again, I'm sorry, I'm kind of mumbling the last couple slides here as I am getting tired. Okay. Next one, graph in polar mode on your calculator. Find an interval for which the graph is traced only once. Okay. So these are a preview to lots of petals. And somewhat visually, it's going to start looking like boom, 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 boom. And that's not even close to what it looks like because I am not a TI. But we have a TI. So 3 sine 5 theta over 2. So let's look at this. 3 sine of 5 theta divided by 2. 3 sine of 5 theta divided by 2. And I'm going to go to my mode. I'm at my window. I got 0 to 2 pi. Okay, let's see what this does. So it graphed it. I don't think I need the negative 10 to 10 all the way through. So let me go back to the window. Let's see if I can change this to maybe like negative 5 and 5 and negative 5 and 5. Okay, now let's graph it. So there it is. Now if you notice, it's not really round. It's kind of lots of line segments. The best way to smooth something out if you're doing polar is on your window. Right now I have 0 to 2 pi, but I'm going up by 0.314s. Let's see if I can maybe go up by like pi over 100. So I smooth it out a little bit more. Let's see what happens. And now it's going, and you can see it be a little bit more curvy as it's starting to make tons of petals. But if you notice, I feel like that's not symmetric yet. I feel like there's some missing petals on the left. So right now I went from 0 to 2 pi, and it wasn't good enough. I'm going to go to window, and I'm going to try 3 pi. And I'll still keep it as pi over 100. And we'll graph. And I'm hoping to see where it starts to overlap with itself. Because at some point it will start overlapping with itself. And I'm getting more and more and more, and this is good. But it stopped. And I still feel like it did not finish the job. So I think I'm going to go one more time and try 4 pi. And graph it, and let's see if it finally seems to make the complete flower, or the complete petal. So it's rotating. Looks like I have 6, 7, 8, 9, 10. 10 petals. And I feel like that is symmetric. Everything's symmetric. I don't think you can really fit in another petal. If you want, you could try another one. If I do the window here and let's say 5 pi, when you graph this, it's going to still do the 0 to 4 pi, which is going to loop around where you get the 10 petals. And we're going to see what happens between 4 pi and 5 pi, and we're going to see if more petals happen. There's 4 pi. Am I getting more petals? Am I getting more petals? Am I getting more petals? No, because what's happening now is it's just overlapping that. And it's just overlapping it again and again and again. So the question said, graph in polar mode, check. Find the interval so it only traces it once. And that interval, to me, was that one. Okay? And it gave you a thing with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 petals. So that's the best I can do. Okay? And again, if it went past the 4 pi, it would have just been lapping that same flower again and again. So hopefully those were some good examples for you guys to practice on. And here is finally your homework, which again, you're going to have a good 30 to 40 minutes to work on it, 1 through 45 odd. So I'm hoping that Thursday's lecture and today's lecture did go okay. I kind of made sure that these were kind of basic lectures on just working with formulas and manipulations. Tomorrow I'll come back, and if you have some big questions, I'll save the day. I'll be here at lunch, and we can go over things and work from there. And actually, I think I might be gone for lunch because I have to learn how to proctor ACT for you guys. Anyway, so I'll see you 4th period tomorrow, and we'll dive back into all of this. Hope you're doing well, and it'll be good to catch up. See you guys.